What's up? Welcome to Maths with Gastin. I am Gastin Mapala. Welcome to yet another video, Analytical Geometry, grade 10. Today, let's have a look at this example. What you see right there, that's the example, and it's got 5 questions. We see we've got a triangle. We're not sure what type of triangle it is now, whether it's right angle or not. But we will soon find out when we continue with this question. So they want us to find, let's just have a look at this triangle a little bit. We've got a H here. The coordinates of H are unknown. We've got E with the coordinates, F with the coordinates, and then G with its own coordinates. So let's go ahead and let's have a look at the first question that is given here. It's saying that question number 1 says we need to find the coordinate of H, which is the midpoint of EG. Okay, so we've got the coordinates here of E. This is just a straightforward question. And then G1 is to 1. Okay, so now let's say for an example this was going to be x1, y1. Let this one be x2, y2. Okay, and then we know the equation of a midpoint. You can have a look at this one, guys, on your formula sheet. Midpoint is given by x1 plus x2 all over 2, excuse me, and then you must have y1 plus y2. Some prefer, I've seen a lot of teachers prefer to use letters in this case, but you can use letters. It doesn't matter. It's fine. If you want to use letters, you can just simply say x at E or y at G. It doesn't matter really. The answer will be the same. All right. Okay, let's come here and say substitute here x1. x1 is minus 2, and then x2 plus 1 all over 2, and therefore y1 is 7 plus y2, which is 1 all over 2. Excuse me. And then when you put this in your calculator, you should be able to get to 1 over 2 is 2. Oh, sorry, minus 1 over 2 is to 4. Okay, so therefore this would be the equations of H. This will be the coordinates of H rather, which is the midpoint here. So we know what is H. Let me just put it here on the diagram. It's minus half is to 4. Great stuff. Okay, and then question number 2. Let me just put a line here to separate this from the question so that is clear. Number two says we need to find the equation of EG. We need to find the equation of EG. So in order for us to find the equation, we're going to use this equation of a straight line here, which is y minus y1 is equals to the gradient of EG, okay, in brackets x minus x1. Okay, so we don't have the gradient. We need to find the gradient first. Therefore, we know that gradient is going to be given by y2 minus y1 all over x2 minus x1. Okay, great stuff. So now let's substitute this into our equation. We already have x1 y1 here of EG. We already marked them here at the top here. Okay, so y2 is going to be 1 minus 7 all over x2, which is 1 minus into minus 2, close bracket. Therefore the gradient of EG should be equal to, if you go and punch this in your calculator, you should end up with minus 6 over 3, which is going to give us minus 2. Okay, so the gradient is minus 2. Great stuff. So now we can come here. In terms of this equation of a straight line, we use any coordinates. We can use the coordinates of E or the coordinates of G. But for the sake of this calculation, I'm just going to use the ones for E. Okay, we have got the gradient. Let me come up here. Y minus 7, because it's y1 at E, is equals to, I'm taking this up here, then substituting it there. Our gradient is minus 2. It's negative 2 x minus x1, which is into minus 2, close bracket. Y minus 7 is going to be equals to minus 2, then x plus 2. Okay, therefore if you exchange this, then you take 7 to that side. Let's see what's going to happen. And also we remove the bracket here, binomial guys. Negative 2x minus 4, then 7, jump the equal sign, is going to become positive 7. We're going to be left with y is equals to minus 2x plus 3. Okay, you can double check this. You can check this equation, check by substituting the coordinate of g, which is 1 is to 1. Okay, so you can also substitute. If x is equals to 1, what will be y? Y needs to be 1. If it's not 1, then you would know that you have made a mistake. So please, I suggest that you double check and calculate very carefully. Okay, all right, now let's come to number 3. Number three is saying that we need to find the gradient of gf. Okay, let's come here. Gradient of gf is going to be equals to the same. We already have the formula here. Okay, let me just put the coordinates here rather, of g and f. Okay, g is 1 is to 1, and then therefore f would be what is f? F is 3 is to 3. Okay, so if you substitute this into the equation here, sorry, if I'm struggling with flu, guys, please just bear with me. I'm trying to continuously make as much lessons and as much example as possible, and continuously post every day as promised. So yeah, just bear with me. All right, so now we're gonna come here and say let x1 be that one of g, sorry, y1 be that one of g is going to be 1 minus 3, and then also here we're going to have x1 is going to be 1 minus x2, which is 3. Therefore the gradient here will therefore be minus 2 over minus 2, which is 1, which is therefore 1. Okay, so fg is equals to 1. Okay, all right, let's jump on into the next page here since we're running out of space. Okay, next page, let's have a look at this one. Now we need to find the gradient. We managed to find the gradient of fg on the previous page. It was 1. So now we must find the gradient of ef. Okay, need to find the gradient of ef. Okay, let this one be coordinates at number 1. Let this one's coordinate as number 2. I'm trying to use as many scenarios as possible so that you guys may understand. But if you don't understand, I suggest that you go and watch the video on lesson on analytical geometry grade 10, and also watch the example that we did, the first example previously from this one, so that you'll be able to understand. Okay, great stuff. So let's come here. I'm going to say y2 is going to be 3 minus y1, which is 7. X2 is going to be 3 minus x1, which is minus 2. Close bracket. We're going to have minus 4. And therefore, here at the bottom, we're going to have 5. Okay. So now this is the gradient of EF. Thank you very much. Now let's have a look at equation number 4. Question number 4 is saying that number 4 is triangle EFG a right angle triangle. Remember guys, for it to be a right angle triangle, this one here HD needs to be perpendicular. So we need to prove that the gradient, the only way to prove it, you must say the gradient of GF should be such that when it's multiplied by the gradient of, if you multiply by the gradient of E, if you multiply it by the gradient of, if you multiply it by the gradient of E, G, they should be give you -1. Okay, so if they don't give us -1, therefore it means, therefore this, they are not perpendicular, and therefore this is not a right angle triangle. So we can see from the gradients that we have calculated that none of them, if you multiply them together, will give us -1. For an example, the gradient of GF is 1 multiplied by the gradient of EFG, of EG rather, and we know that the gradient of EG was -2. So therefore, when you multiply these two things together, they don't give you -1. Therefore, this triangle EFG is not a right angle triangle. And our reason is that the gradients, they are not perpendicular. It's not a right angle triangle. Okay, great stuff. So now let's come to number 5. Let's come to number 5. Number 5 is saying, we need to find the equation of a perpendicular bisector of EG. Okay, so we already know the gradient of EG. The gradient of EG, it's -2. We already know it. Okay, so we need to choose a one, the equation that is going to pass there by H, a perpendicular bisector. You're looking for this line here. Okay, so we know that the equation, the gradient of EG, we know that the gradient of EG is equals to -2. So we're looking for the gradient at H. This would have to then be, when you multiply them together, they must give you -2. So they must give you -1 rather, sorry. Therefore, this is half. So that when you multiply together with this one, the gradient, they must give you a -1. Okay. So now we're going to go ahead and use our equation of a straight line here that we are all familiar with by now. Okay, and then we're going to use the coordinate at H, which is -half. We calculated them previously. Half is to 4. Okay, so come here, we substitute y -4 is equals to the gradient, which is 1/2 x minus into -half, then it's going to give us +half, close brackets. Therefore, once you put this in your calculator, you're going to say y is equals to half x plus 1/4 plus 4. When you take that, this 4 to this side, it must be +4. Okay, so if you take a look at this and then you add everything together in your equation, you must be able to get y is equals to half x plus 17/4. Okay, and that's how you deal with this equation like this one, guys. If you don't understand, please make sure that you leave a comment on the comment section below, and please just bear with me. I'm trying as much as I can to get to make sure that I upload one video every single day. And please make sure that you stay tuned, subscribe to my channel. I am Gastin Mapala. See you on the next upload.